All right, if you're in nursing school, you know that medicine is basically a whole other language. Today, we are going to break down some of the most critical terms you'll ever need to know, the words that describe perfusion and oxygenation. And trust me, mastering this isn't just about passing an exam, it's about understanding the literal life or death dance happening inside your patients. So here's our game plan. We'll kick things off with the absolute basics. What even is perfusion? Then we'll dive into what happens when that flow gets blocked. After that, we'll talk about its critical cargo, oxygen, and what happens when we run low. We'll also cover how you can read the body's signals, and finally, we'll look at the big one. What happens when the whole system starts to fail? Let's get into it. But before we get bogged down in definitions, let's just think for a second. What is the single most important job in the entire human body? You know, your mind might jump to the brain, sending out commands, or the heart doing its steady beat. But really, when you boil it all down, it comes down to one simple thing: delivery. Just getting the right stuff to the right place at exactly the right time.
And that, right there, brings us to our first section, perfusion. Honestly, the easiest way to think about it is as the body's ultimate delivery service. It's like an Amazon Prime that runs 24/7, nonstop, to every single address. And by address, I mean every single cell in your body.
So what is it really? The textbook definition is the volume of blood that flows through target tissues. But let's make that real. Perfusion is the process of the delivery truck, your blood, successfully getting to its destination. It drops off those essential packages of oxygen and nutrients, and just as important, it picks up all the cellular trash and waste products. Without this delivery and pickup service, absolutely nothing else works.
Now, this is a really important distinction to make. We have two types. First, there's central perfusion. Think of this as the main engine, the central warehouse. It's the heart pumping out a certain amount of blood every single minute. That's your cardiac output. But then you have tissue perfusion. This is the last mile of the delivery. This is the blood flowing through those teeny tiny capillaries to feed the individual cells. See, you can have a massive, powerful engine, but if all the local roads are blocked, the packages still don't get delivered. You need both. So what happens when those deliveries get delayed, or worse, stopped completely? This leads us to two of the most critical words you will ever learn in nursing: ischemia and infarction. Knowing the difference between these two, well, it's everything. Okay, first up is ischemia. And the one word I want you to burn into your brain here is reversible. Ischemia is a warning sign. It's the tissue basically screaming for more oxygen than it's getting, because the blood flow is cut down. It's like a massive traffic jam that's slowing down all the delivery trucks. The cells are definitely getting injured, they are not happy, but if you can clear that traffic jam in time, they can fully recover. It's reversible.
But if you don't clear that traffic jam, if you ignore that warning sign, you get infarction. This isn't a warning anymore, this is the consequence. Infarction is the actual death of the tissue. Those cells were starved of oxygen for way too long, they've died, and, this is the crucial part, they cannot regenerate. The damage is done. It's permanent. This is a heart attack, a myocardial infarction. This is a stroke.
Take a look at this. This progression is the whole story. It starts with healthy, normal perfusion. Then some kind of problem comes up, and that leads to ischemia, the reversible injury. This is your chance to act. But if that problem isn't fixed, it keeps going down the path to infarction, irreversible tissue death. As a nurse, your job is to live in that middle zone, to spot the signs of ischemia and intervene before it ever gets to infarction. Okay, so we've talked a lot about the flow of blood, the delivery trucks, but now let's talk about its incredibly precious cargo, oxygen. And just like with blood flow, there's a spectrum of danger when it comes to oxygen. It's a slope that goes from just being a little low all the way down to a complete and total absence. This progression right here is absolutely key. It starts with hypoxemia. Here, the problem is in the blood itself. There's just a low concentration of oxygen in the arteries. If that goes on, it leads to hypoxia. Now the tissues in the cells aren't getting enough oxygen to do their jobs. And the final, catastrophic stage? Anoxia. That's a total, complete lights out and absolute absence of oxygen. Think of it like this. Hypoxemia is the warning, hypoxia is the injury, and anoxia is the endgame.
Okay, so all this stuff is happening on a microscopic level, right? So how in the world are we, as clinicians, supposed to see it? How can we possibly diagnose it? Well, the body is not quiet about it. It sends up flares, it gives us very clear signals, and our job is to learn how to read them. It is so important to connect these clinical signs to the real problem. For example, if your patient is hypoventilating, breathing too slow or too shallow, they're not bringing in enough oxygen. That can easily cause hypoxemia and lead to hypercapnia, which is a buildup of CO2. Or what if your patient has anemia? Here the problem is different. They don't have enough red blood cells, not enough delivery trucks to carry the oxygen, so their tissues suffer even if their breathing is perfectly fine. And then there's cyanosis, that bluish tint to the skin. That's a big visible clue, but you gotta know, it's often a late sign that things are already dangerously low.
So far, we've mostly talked about localized problems, right? A blocked road here, a delayed delivery there. But what happens when that delivery network failure becomes widespread? What happens when the whole system goes down? This is when we see catastrophic, system-wide failure, which we call shock and respiratory failure.
Shock is the ultimate perfusion problem. I mean, it is the nightmare scenario. It's defined as systemic, and that means body-wide hypoperfusion. The delivery system isn't just failing in one neighborhood, the entire national network is collapsing. This leads directly to widespread tissue hypoxia, and if it's not fixed, and I mean fast, it leads to multi-organ failure and death. Every single term we've learned so far leads to this.
And right there alongside shock, you almost always find respiratory failure. This is when the lungs just can't do their job anymore. They can't get oxygen in and they can't get CO2 out. And the two create this vicious, terrible cycle. The respiratory failure makes the shock worse, and the shock makes the respiratory failure worse. This is the moment when the body's most fundamental systems are shutting down. So let's end with this question. To bring it all home, why does this vocabulary matter so much? Because being able to recognize that a patient's chest pain is a sign of reversible ischemia and not yet a full infarction is what lets you jump in and actually save their heart muscle. Understanding that hypoxemia is the warning sign that comes before hypoxia is what makes you act before cells start to die. This isn't just a list of words you have to memorize. This is the language of life and death, and mastering it is one of the most powerful things you will ever do as a nurse.